Hi, welcome back to Math's Playground. Today we're going to be working on some logarithm proofs, and I really hope you know what logs are. Not the wooden logs you cut from trees, but the math logs. Because after all, this is called Math Playground, not tree. So, we're going to have three proofs today, and our first one is we have to prove that log z ABC is equal to log ZA plus log ZB plus log ZC. So first, let's say log ZA is equal to Y, log ZB is equal to X, and log ZC is equal to W. So then A would be equal to Z to the Z to the power of Y, B would be equal to C to the power of X, and lastly C would be equal to Z to the power of W. It's much easier like this because now we don't have crazy long things to write. So now let's start with this. ABC, according to these three, ABC is equal to Z to the power Y times Z to the power X times C to the power W. And since we have to prove that log Z ABC is equal to log ZA plus log ZB plus log ZC, we're going to take log Z on both sides. So we get log Z ABC is equal to log Z. We can turn this into Z to the power Y plus X plus W. So we have log Z and Z. So we end up with log Z A B C is equal to Y plus X plus W. And now we can replace Y, X, and W. So we get log Z A B C is equal to log ZA plus log ZB plus log ZC. So we have our first proof. Our second proof is very similar to this. Okay, now on to our second proof. This, as I said before, this is very similar to our first one. We have log Z of A divided by B is equal to log ZA minus log ZB. We have to prove that this whole thing is true. So like we did before, we can say log ZA is equal to Y and log ZB is equal to X. And from this we get A is equal to Z to the power Y and B is equal to Z to the power X. Now like we did before, we're going to do A divided by B is then equal to Z to the power Y divided by Z to the power X. So since we need to prove that log ZA divided by B is equal to log ZA minus log ZB, we're going to take log Z of this whole thing on both sides. We get log Z a divided by b is equal to log z of z to the power y minus x. Log z and z cancel out, and we're left with log z a divided by b is equal to y minus x, which is equal to log ZA minus log ZB. Hence proved. Now, moving on to our third proof. Okay, now that we've finished our first two proofs, we're going to move on to our third one. We have to prove that log z a to the power n is equal to n log za. Okay, so like we did before, on the first two ones, we're going to do log z a is equal to y. Then a is equal to z to the power y. Then with this information, we have a to the power n is equal to z to the power y to the power n. But we don't have to prove this. We have to prove that log z a to the power n is equal to n log z a. So let's take log z on both sides. So log z a to the power n is equal to log z. This whole thing is going to turn into z to the power y n. Log z and z cancel out, and we're left with log z a to the power n is equal to yn. So you can turn that into log z a to the power n is equal to n log a. Hence proved. 3 proofs, all done.